Hello everyone, welcome to Physics Tutorials. My name is Ganga Bhavani. This is session 1 in kinematics. In this session, we are going to discuss about rest and motion, what is distance, displacement, speed, velocity, acceleration, and how to calculate average speed, average velocity, average acceleration. Let's see first rest and motion. Friends, when do we say that a particle is moving? Or when do we say that a particle is at rest? We all know if a body does not change its position as time passes, then we say it is at rest. Let's say a book is placed on a table and it's not moving. So it is at rest. Like that. If a body changes its position with the time, then it is said to be moving. Let's say a bus is going from one place to another place. So it's nothing but it is in motion. So motion is a combined property of the object under study and the observer. There is no meaning of rest and motion without observer. Actually, nothing is in absolute rest or in absolute motion. To locate the position of the particle, actually we need a frame of reference. What is frame of reference? It's nothing but with what we are comparing and observing the rest and motion of a body. Let's say a table is located in a room and it's not moving according to the room. Means it is at rest if we see in room frame of reference. If you see same table from the surface of the moon, as per the moon, earth is moving, means table is also moving. So, as per the room frame of reference, table is at rest, and as per the moon frame of reference, table is in motion. Actually, one more convenient way to fix up the frame of reference is to choose three mutually perpendicular axes and name them as x, y, z. If all three coordinates remains unchanged, then the particle is at rest. If any one of this coordinate is moving with time, then we say that particle is moving. So like this, we can analyze rest and motion of any particle according to any frame of reference. Let's see what is distance. Distance, the actual length covered by a particle along its path. Distance is a scalar quantity, means it has only magnitude. Let's say a person is walking along a path. So, how much ground the person has covered is nothing but distance walked by the person. Let's see what is displacement. The shortest length between initial position and final position. Displacement is a vector quantity. Usually, distance and displacement both are same. Whereas, distance is a scalar quantity and displacement is a vector quantity. While we are using both magnitude and direction, we consider displacement. Without direction, we consider only distance. Let's say a person is walking along a semicircular path. So the length or the distance between starting and ending points represents his displacement. If the same person is walking along the circular path, so there the initial position and final position of the person is same. So there is no distance between initial position and final position. So the displacement is 0. If any particle is moving along the circular path, the displacement of that particle is 0. Let me give one more example. Let's say a particle is moving in a coordinate system x, y, z from point A to B. Now the particle is at A at time t1 and it is at B at time t2 with respect to this frame of reference what we have taken, that is x, y, z. During this time interval t1 to t2, the particle moves along the path ACB. So here ACB is called the distance travelled by the particle. So if we join the initial position and final positions with a straight line, it will give us the displacement of the particle. It's nothing but the shortest distance between initial position and final position. So distance is nothing but the actual distance covered by the particle, actual ground covered by the particle. Displacement is nothing but the shortest length between initial position and final position. So like this, we can analyze distance and displacement. Let's see what is speed. The rate of change of distance is called speed. This is a common definition what we know about speed. Speed is a scalar quantity like distance. Means it has only magnitude. Let's say the distance traveled by a particle is s and the time taken to cover that distance is t. So we can write a speed v equals to s by t. It's nothing but change in distance with time. Let us see how to calculate average speed. Average speed is nothing but the rate of change of distance in a particular time interval. Means if the particle travels a distance s in a time interval t1 and t2, so we can write the average speed as s by t2 minus t1. The average speed gives the overall rapidity with which particle moves in that particular time interval. Let's say in a one-day cricket match, how they will calculate the average run rate? They'll calculate average run rate as the total runs divided by the total number of overs used to make those runs. So means average speed is a rate. It's always a quantity divided by the time to get that quantity. Let's see what is velocity. The rate of change of displacement is called velocity. Like displacement, velocity is also a vector quantity. Means it has both magnitude and direction. That's why I am representing it with an arrow. So v bar equals to d by t. Here d is the displacement of the particle and the t is time taken to cover that displacement. Let us see how to write the average velocity or how to calculate the average velocity. Average velocity is nothing but the rate of change of displacement in a particular time interval. Let's see, as per this figure here, if we consider AB bar is the displacement, so it's nothing but the displacement covered by the particle. So I can write the average velocity as AB bar divided by the time intervals, that is T2 minus T1. Let's see what is acceleration. Before going to discuss about the acceleration, I want to mention a small point here. I want to give a difference between speed and velocity. Velocity is the speed with the direction, while speed does not have a direction, because speed is a scalar quantity, velocity is a vector quantity. Whenever we want to represent with the direction and magnitude, then we can go for velocity, because scalar is speed is a scalar. Okay, let's go and have a look about acceleration. If the velocity of a particle remains constant as time passes, means if the velocity is not changing with time, we say that it is moving with uniform velocity. There is no change in velocity, so it's moving with uniform velocity. The velocity changes with time, it is said to be accelerated. So the rate of change of velocity is called acceleration. So we can write acceleration as a equals to v by t. It's nothing but change in velocity with time. Let's say a ball is falling from a building. The velocity of ball is changing with time, that we know. Means the ball is accelerating. So when we drop the ball from a building, so the initial velocity of ball is 0. While it is traveling from top to bottom, the velocity will increase. It's nothing but the change in velocity, the velocity is changing from 0 to higher. So when we consider the freely falling bodies, they are accelerating with Earth's acceleration, that is nothing but g. Let us see how to calculate average acceleration. Let's say the velocity of particle at time t1 is v1 bar and at time t2 is v2 bar. The change produced in this time interval is v2 bar minus v1 bar. So we can write average acceleration as v2 bar minus v1 bar by t2 minus t1. Average acceleration will be equals to the acceleration, initial acceleration. Again, the average acceleration depends only on the velocity at time t1 and t2. How the velocity changed in between t1 and t2 Actually, it's not much important in defining the average acceleration. So hope you all got the clarity about all these physical quantities. Hope you all like this session. See you soon in the next session. Thank you.